Hello children, welcome to channel Sube. Children, today I am going to discuss question number 47 from the MCQ part of 2022-23 Physics New Syllabus paper. Ambient air at 30 centigrade degrees and relative humidity 90% is cooled to 10 centigrade degrees, and some of the moisture in air is removed by an air conditioning plant. Then this air is heated to 20 centigrade degrees and passed to a computer laboratory. If the values of saturated water vapor pressure at temperatures 10 centigrade degrees, 20 centigrade degrees and 30 centigrade degrees are given by simple A, simple B and simple C respectively, what is the ratio of moisture removed from the plant and the final relative humidity of the air at 20 centigrade degrees? So children, there are 5 answers. Now we have to start to solve this problem. So children, before we go to solve this question, I have something important to tell you. In these types of questions, calculating relative humidity, in this lesson we don't calculate pressure change according to the temperature change. Pressure change according to the temperature change we don't calculate. Suppose there is a pressure, vapor pressure, the value is 26 mercury millimeter. Suppose that is the vapor pressure at say 27 centigrade degrees. Then suppose this room is heated up to 37 centigrade degrees. The rise is 10 centigrade. So here there is this vapor. So the pressure we don't calculate according to this temperature rise. Even though we calculated, we get the very approximate value using Charles' second law. Like this we can calculate, but usually we don't do that. P1 is 26 in mercury millimeter. Then absolute temperature is 300, because we have to convert this to absolute temperature by adding 273 degrees, you know that. So P2 is what we are going to calculate now. Now I am going to show you, not this question. Then T2 say 37, then 10 degrees increase, then 310. So if you calculated P2, 26 times 310 divided by 300, 26.8 mercury millimeter. So initially it was 26, now it is 26.8. only the change is 0.8 mercury millimeter. We don't calculate like this, children, in this topic, because we are in an atmosphere where the atmospheric pressure is 760 millimeter Hg. So we are feeling this pressure. According to this pressure, this 0.8 millimeter is nothing. It is nothing. So therefore we don't calculate like this. We just take the pressure in these types of calculations as same as 26. So that I have to mention you at the beginning itself. Right, now let us start to solve this problem. So in this story there are three instances. There are three rooms, so we have to draw. First it was at 30 centigrades and then cooled down to 10 centigrade, and after that heated up to 20 centigrade and sent to the laboratory, computer laboratory. So here there is a vapor sample, here there is a vapor pressure. So they have mentioned that the relative humidity at centigrade 30 centigrade is 90 degrees. So relative humidity is 90. So the saturated water vapor pressure is given respectively 10, 20, 30 A, B, C. At 10, capital P is A. At 20, capital P is the saturated vapor pressure, you know that. Then this one is B. So at 30, capital P they have given as C. So we have to use these values. C. So the vapor pressure actually in this room is denoted by simple P. So what is this? Capital P is the maximum vapor pressure. Maximum vapor pressure, it can be equal to C. But now we are writing the real time vapor pressure, simple P. So it is equal to, I can write in 0.9 times C. How I did that? The equation is relative humidity equals simple P divided by capital P times 100. So using this, we have to substitute this given value for relative humidity 90. Then simple P we don't know. Capital P they have given as C. Then times 100. So simplify this, what do you get? We get simple P equals 0.9 times C. So that is what I did without writing all these things in my head. All these things ran and I wrote like this. So you can write it like this. So then what they did, cooled down this room down to 10 centigrade degrees. And also they say that certain amount of moisture, what is the ratio of moisture removed? Pressure at if the is given, what is the using an air condition, some of the moisture in air is removed by an air conditioning plant. So before removing moisture, what does do these types of air conditioning plants? Using air conditioning plants, what we do, we cool this room to such a temperature such as 10 centigrade from 30. Then what happens? The moisture, the cooled vapor condensed on the tray. There is a tray in the air conditioner machine. So accumulate as liquid water. So this one is liquid water. So moisture is removed like that. Moisture means the vapor. So now this vapor is in contact with liquid water. In such a case, we call it is a saturated vapor. Saturated vapor. So if the vapor is saturated, the real time vapor pressure, simple P, the real time vapor pressure is equal to the maximum vapor pressure. It is given as A. So simple P is equal here to the value simple A. It is given. Or you can write on the other hand like this. If the room is saturated, the relative humidity we can write as 100%. Relative humidity is 100%. So using this equation, That way also you can calculate, but in short form you can take like this. So relative humidity is 100 here, because they don't say that. We have to use our common sense to identify that, because they say some of the moisture in the air is removed. So you should know how to do that. If you don't know how an air conditioning machine is working, you will not be able to solve this problem, I think, because you don't get the idea that the vapor is first should condense like this in the room or in the machine like this. So if that you don't know, I don't know how to solve this problem without knowing that knowledge, without having that knowledge. So simple P is what we are going to now find out. So capital P they have given as simple A times 100. So 100 cancel. So we get simple P equals simple A. So this thing you don't have to do actually. You can use your common sense. If the vapor is saturated, there are maximum vapors. There is maximum vapor. So that way you can decide that simple P is equal to simple A, that is given. That is the maximum. So now what they ask is, first they ask the ratio of moisture removed. Ratio of moisture removed. Let us try to find out that. The ratio of moisture removed. Ratio. So we can find out that using at 100 centigrade the moisture, no, let us write vapor. Vapor collected. That is the vapor removed. That is the vapor removed. So ratio means now we have tried the initial vapor, initial amount of vapor. Initial amount of vapor is this one. Divide by initial amount of vapor. So this is what ratio of moisture removed, meaning ratio of moisture removed. You have to get the ratio to the initial amount of vapor. So what is the initial amount of vapor? Initial means at centigrade 30. The initial amount of vapor, actually the amount of vapor is this, given by this simple P, real time the vapor, simple P, 0.9 times C. This is the initial amount of vapor. So how to find how much vapor collected and removed? How much, that is equal to this amount of liquid water. It is equal to this amount of liquid water. So we have to find out the pressure given by that, if it were as vapor in this room, if it were as vapor in the form of vapor in this room. So now in this room, after condensing, the pressure given by the vapor in this room is simple P. At the beginning it was 0.9 times C. So the difference is this one. The difference is this one. So we can find out the difference. So 0.9 C minus simple A. Simple A. Simple A is the amount of vapor pressure given by the vapor actually now in the room. So this one is the initial vapor pressure which was at 30 centigrade, that was in the room. So if we subtract what we get, the vapor pressure removed, the vapor pressure removed, it is the numerator. So the denominator is initial amount of vapor 0.9 times C. So this is the answer, first answer. This is the first answer. So we can choose this one. Only we are looking at this one, this term. Let us do this later. So this one is also seem to be correct, because the first part is correct. So others are entirely wrong. Here 0.9 is missing, and these are totally wrong. So therefore now we have done half of the problem. So let us now try to solve the second part of the question. What is it? The final relative humidity of the air at 20 centigrade. 20 centigrade is this one. So what they have done after collecting this water and removing the vapor which was in this room has been transferred to the the computer laboratory. So suppose this one is the computer laboratory. The same vapor is here. The only change is the temperature has been increased up to 20 centigrades. So the pressure is the vapor is the same, but it is not saturated here. Here it is not saturated, because the liquid water here you can't see. The liquid water here you can't see, because the liquid water was removed right here. The liquid water was removed right here. So here no liquid water. So if there is no liquid water, if there is only the vapor pressure, so this one is unsaturated. It is not saturated, unsaturated. So therefore you can't say that the pressure given by this vapor is this one, equal to this one, as here. Since in this room the vapor was saturated, therefore the real pressure given by the vapor was equal to the maximum pressure. But here, since it is not saturated, that condition is not here, this room is unsaturated, therefore the real pressure given by the vapor is something else. It is not equal to the maximum, simple B, it is not equal to the simple B. So this one is something else. So we have to actually calculate, this was the previous pressure, simple A, then the temperature change is 10 degrees, the temperature rise is 10 degrees. So actually we have to calculate this pressure, what will be given at 20 centigrades, like using that P1 divided by T1 equals P2 divided by T2. But we don't calculate this at the beginning itself. I showed you that even though we calculated, the temperature change is very little, therefore the pressure change is very little, so we don't have to consider that we neglect. So the pressure is given, therefore at 20 centigrade is the same as it was at 10 centigrade. So here the pressure is simple A equals to this previous one. So now we can write the equation for relative humidity. That is what they ask here in this room. So it is equal to simple P divided by capital P times 100 times 100. So simple P is simple A, then the maximum pressure it would be if it is saturated is capital P, so it is equal to simple B, so they have given, we have to take it as it is, B times 100. So this is the only thing we have to do. So this is the relative humidity. 100 times A divided by B. Let us check the answers. 100 times A divided by B percent. So this one is the final answer. This one is wrong. Therefore, we have to decide. The answer is the first one. So let us check the answer sheet. 47, the first one. The answer is first one. So correct. So that is how we should solve this problem, children. So let us now do some target questions. I think you understood because I step by step using colors explained so that you can understand. I think I am successful. So let us go to the target questions. Children, before we go to the target questions, I have something important to tell you. To answer this question, you should thoroughly identify and understand this process. That means how an air conditioning plant, what they say, air conditioning plant. Normally we say air conditioner. So how an air conditioner functions, you should know. Otherwise, I think you will not be able to understand this story properly. So in an air conditioner, there is a tray to collect liquid water, to collect condensed liquid water. So like this. So after collecting like this, the water is removed right here. There is a tube. So the end of the tube is outside the building. So using that tube, the collected liquid water is removed. So there is a big box at air conditioned buildings, you might have seen, outside of the building. So there is a big fan like this. There is a big fan, and there is a radiator also. There is a radiator. If you move close to this one, you might feel hot air leaving this box, and also water on the ground. Water on the ground, that is coming from that tube. So that is what happening in these air conditioning machines. So the water is removed, liquid water is removed right here. So it is not going to the inside room. It is not going to the room. So to the room, filtered pure air with vapor, certain amount of vapor is pumped. Not liquid water is transferred to the room back, from the machine to the room back. Filtered air is pumped with certain amount of vapor. Not all the vapor is removed. If all the vapor is removed, it will be very hard to breathe even. You will get your mouth dried up and also nose dried up, and very difficult to stay in a very dry feeling. You will feel very dry, and sometimes you get cough. Therefore, a certain amount of vapor should be there in that air. So the relative humidity is given from this equation in the computer laboratory. So now let us go to the target question. Children, I prepared a target question for you. Here it is, the target question number 1. So try this without looking at my answer. Honestly, pause the video first and write. Now pause the video. So children, since you have paused the video, now I am going to start. If the relative humidity is 90% of a room at 30 centigrade degrees, what is the partial pressure of water vapor in the air of the room? So here the relative humidity is given as 90%. The temperature is given 30. What is the partial pressure? Partial pressure is simple P. That is what they want us to find out. Partial pressure. So the data is given as 30 at 30 centigrade. The saturated vapor or water vapor pressure is 32. So capital P is given. Capital P is 32 in Hg millimeter. So the equation for relative humidity we can use simple P divided by capital P times 100. So relative humidity is 90. Simple P is what we have to find out. Capital P is 32 times 100. Then isolate P, simple P, 90 times 32 divided by 100. 90 times 32 divided by 100. No such an answer. So let us simplify this a little bit. So divide by 100 is 0.9 times 32. Let us check that. See here 32 times 0.9. This one is the answer. Fourth one. This one is the answer. So millimeter Hg. Here children, I prepared target question for you. Target question number 2. Now try this honestly without looking at my answer. Now pause the video. Since you have paused the video, now I am going to try this. The relative humidity of a room was 90% at 30 centigrade. So let us draw the room. Ninety percent relative humidity, 30 centigrade. Relative humidity, if the temperature of this room is decreased down to 10, here the temperature is 10. A certain amount of vapor was condensed as liquid water. Certain amount of vapor condensed as liquid water. Then as soon as you saw this, you have to decide that the vapor is saturated, otherwise you will forget it. Vapor is saturated. That means simple P equals capital P. So capital P is given at 10 centigrade 9 millimeter. Capital P is 9 millimeter. Then that must be equal to simple P. Hg millimeter. So in the question, vapor was condensed as liquid water. Now what would be the relative humidity and the partial vapor pressure at 30? Now what would be the relative humidity? That means at centigrade 10. Here relative humidity is 100 because saturated. 100%, you don't have to calculate. Since it is saturated, the pressure is the relative humidity is 100, because both the pressures are equal. Even though you substitute those equal values to the numerator and denominator, they get cancelled and you get the 100% answer. So this one is going to be correct, and also this one is going to be correct. Still we can't say, we have to check the second part. So what is the, so even though you simplified these things, these terms, you don't get 100%. So therefore totally wrong. This one also the same. The second part, now what would be the relative humidity and the partial vapor pressure at 30? Here partial vapor pressure they ask. So what is the capital P value here? At 30 respectively 32 millimeter. So what is the simple P? Directly I write 0. Because the relative humidity is given as 90, 0.9 times 32. This is the partial vapor pressure. So I don't write the equation, total equation, or relative humidity equals simple P divided by capital P like that. That thing you should do in your head, and directly you should be able to now write as this. So the second part of the answer is this one, 0.9 times 32. So here the first one is the answer. Here there is extra 100, it is wrong therefore. So the answer is first one for the question 2. Children, here is our next target question, number 3. Now try this on your own without looking at my answer. Pause the video. Since you have paused the video, now I am going to try this question. So the room is like this, at the beginning, after that like this, and a closed room with a temperature 20 centigrade is heated to, so initially 20, finally 30. When there is a certain amount of liquid water in the room, there is a certain amount of liquid water in this room. So as soon as we came to that, what should we decide? That the room is saturated, because the air is in contact with this touching the liquid water, so this one is saturated. That means capital P equals simple P. So capital P is given at 20, 17, then simple P also 17, relative humidity 100%. Because if a room is saturated, the relative humidity is 100%. Now after increase in the temperature up to 30 degrees, the liquid water disappeared, completely disappeared. So there is no liquid water. That means this room is not saturated, it is unsaturated. Unsaturated. So that means capital P and simple P are different. Capital P is given when the temperature is 30, it is 32 millimeter, Hg millimeter, mercury millimeter. So simple P, we don't know. What they ask, now if the partial pressure created by the vapor is 10 divided by 9 partial pressure now, so here simple P is that partial pressure 10 divided by 9 of the previous pressure. Previous pressure was 17, then times 17. then the relative humidity of the room is now. Relative humidity is what they want us to find out. So let us write the equation. Simple P is this one, 10 divided by 9 times 17. Capital P is 32 times 100. So this is the relative humidity now. Then the answer 10, 17, 10, 17, 100, 9, 32. This one, second one. Easy, right? So now children, it is time to wind up the video. Now the time is over. So children, what you have to do, if you are happy, collect subscriptions from your home and from your relations, because I need 1000 subscriptions. Still I have 770 or something like that. So until that, the YouTube doesn't pay me anything. Therefore please collect subscriptions from your father, mother, sister, brother, uncle, auntie, grandfather, grandmother, or whoever your relations. And also share my link among your friends and ask them to collect subscriptions for my channel. Lot of subscriptions I need, at least 10 subscriptions from one family. You can do it because everybody has cell phones. So please collect subscriptions for my channel so that I get to this target. And also like this video, then only the YouTube will push this video to the front. So children, thank you very much for watching my videos, and thank you very much for collecting subscriptions for my channel, and also thank you very much for sharing my link, and thank you very much for liking my videos. Then children, see you tomorrow in the evening at 6 o'clock. Goodbye, have a nice day.